Good afternoon. I am Shara. I'm very glad to speak here to share with you how we use the Ali Cloud to do migration of our architecture. So introduce Flipboard. Flipboard is a news app, and this July we released the updated version, and we have our Chinese name. Globally, we cover 200 countries with over 100 million monthly active users. And also the gender mix is quite balanced. In China, we have almost 1.1 million daily active readers, and every week we have 3.3 million people using Flipboard. The most popular interested on Flipboard, we have technology, news, business, and since we have a certain amount of users, in 2016, we decided to migrate our backend services to Ali Cloud from Amazon, which will be easier for our Chinese readers access. And we are facing a lot of challenges, of course. On one hand, it's heterogeneous architecture migration. It's a matured back-end application system. It's developed for 6 to 7 years, and also it uses a hybrid technical stack. It includes an AWS, Ali Cloud's technical stack, and also some popular technical stack for open source. So this is a list of the major technical stack that we use, from middleware to file system to lightweight DB, simple DB. On AWS, we use all the cloud services, and that when we migrate to this part of the service, we found we have similar service to replace the legacy service. We also use some open source technologies like Memocache, Hadoop, Redis, Hadoop, HBase. For this part of migration, we make some really bold attempts, mostly replace our HBase with table store. So to reduce our operation and maintenance workload, and in the practice we found that table store can definitely replace all the functions of HBase. So dependency, and also this is the structure of the Flipboard. It is a classical cloud onboard architecture. So the traffic will come from mobile client and web to internet, then to DNS, and then to CloudFront to backend. For users, we use VPN to visit, and all these are within VPC. And we started with a monolith but a scalable service, but then with the development of our business, we extend from a monolith to microservice, and we started with API gateway. API gateway is responsible for some public modules, for example, register, login, and also the business logic on the back end, and also it can check the legitimacy of inquiry. And also we cover, after a certain time, basically we cover all the development language like Python, Java, C++. So these languages are used for reasons. We are a news app. So we only do RSS, so we use Python. And to do RSS standard, later on we have to also interpret the web page. That's why we started to also use Java. And also we see a lot of domains on the different websites, different rules, different principles. So we use Java. Later on, besides interpretation of the web pages, we also have to analyze the pictures, because the user's app is automatic editing. So we have what we call like a safe editing area using C++ to analyze the images. And then this message will be fed back to the front end, so they know how to edit, whether to reduce the size or to magnify it. And also, with the users' amount increase, we have a lot of parallel mission. So we use Clojure to do a mission calling system. This can submit the mission to the system, and this system can release the mission on a given time. And in China, because we have a limited number of developers, our latest functions are developed with Go, and we just try Scala. And because if it's a programming language, it is really for the third-party API. We can also export content to third-party app. So we use Scala to do that. And also with the development, we don't think that Scala will show in the later business. It will gradually replaced. It will be gradually replaced. And also JavaScript and all Node.js, we believe that it will gradually be used in the future in our backend microservices. So this multi-language environment will use RPC HTTP plus JSON payload. And actually, as we say, we rely on a lot of technical stacks. The backstage developed for 5 or 6 years, and we use all kinds of development languages. And also the maturity is also on the operation and maintenance. It is AWS SDK based, and the script, Puppet scripts and the Jenkins. So this project also developed for 5 or 6 years. And also when we are doing the migration, I think the greatest challenge I feel is really to migrate this operation and maintenance system. It's a huge challenge, the greatest challenge, because it's a heterogeneous infrastructure related. So how do we do the migration? So we renovate our code. Decouple the AWS dependency. If we do not do that, we could not do the migration. Is it complicated? Not really, because for the third party's dependency is only shown in the surrogate layer, and we just change a limited number of the code, so we can guarantee the business is all set. And the changing of the code is definitely controllable. And then use Docker technology to unify to integrate the microservice operation environment. So maybe only like in China, our staff only have certain experience with a certain developer language. So Docker will unify these different languages, and also we using the Docker technology to break down the silos. Last but not least, we use Ali Cloud's PaaS container service to manage our containers and deploy all services. And why we use Ali Cloud's product? Because first, we're still a very small company in China. If we built our own CaaS layer, we feel that the return on investment is too low, and also for the CaaS layer is on the IaaS layer, and the IaaS layer we are on the public cloud. We don't know much about the bottom layer infrastructure. So for migration, and for my cloud migration, the time and the energy is too much if I built my own CaaS. And also compared with other public cloud, AWS and Google, they have their own PaaS managed containers aggregate service.
Also, Alibaba also has the public cloud platform, so we're trying to use the Ali Cloud. And now the container technology is very popular and also a very hot topic. Personally, I think it's still in the developing phase. So when it's getting more and more mature, I think this technology will settle down on the public cloud platform. So this technology will settle down or will be embodied on these products. So no matter what kind of direction or the level will be for the container technology development, I think we will still enjoy the bonus brought by the container technology. This is the Ali Cloud Container Cluster Managing Platform. Actually, we are not very familiar with this architecture diagram of this platform, but you have to know how to use it. This platform has its own URL and commanding line, and it can manage image, and you can build the image, and also it has a service orchestration mechanism. So you can create service, destruct the service, and also operate the service. And also we have used the Docker to package the running environment of the service. You can use the first 4 points to migrate the microservice from the cloud to the container clusters. But since we have used this container cluster, we want to use it in a better way. What's the difference? Under the container cluster, we have the microservice environment, but we didn't use the container cluster because the network is different. So in Ali Cloud, it also provides the service registration and discovery mechanism. So the next step, we use the internal service registration and discovery scheme. All the microservices are in the EPC. And also, first of all, is access to the Ali cloud. The self-defined route of the service registration and discovery, and then it will access the API gateway. For the API gateway, the user can log in and also can log up. And also for each user has the only API gateway, but the Ali Cloud self-defined route does not support this function. But the self-defined route is realized by HA proxy, but we are not before using the container cluster. We also use the HA proxy to realize this function, but we use the Flipboard version HA proxy. And then we found out a solution path. We combine these two HA proxy. The Ali self-defined route HA proxy and our HA proxy combination can help us to address these issues. After communication with the Ali Cloud, they will provide us a basic image. Based on this image, we can compile our own version of HA proxy and then return to the Ali Cloud engineer, and then they will do something on it, and then it will generate the Flipboard version self-defined route. This self-defined route based on some logic combination, and to see at back end which gateway it will be reflected. We are based in Beijing, and Ali Cloud is based in Hangzhou, so we use the doc file to conduct the communication without the loss of information. So this diagram is the Ali Cloud's own service discovery scheme. If we don't use Ali Cloud service discovery scheme, we can also realize the client service discovery. The client service discovery, we use the long service. So when we upgrade the code at backend, we need to redeploy and restart. For the long service, when we start the service, we don't hope that it will pass the downtime, or we don't want to restart the service. So for the long service, we use a more simpler service discovery scheme, the client service discovery. On each ECS, we only deploy one container, and we use the host model to map the network on the ECS. Our memcache configuration information, we use the dynamic configuration approach. We transfer the information to the JIT. I use one operation machine. When the document upgrade, and then we download onto the network disk. This is also a product of Ali Cloud. The NAS can mount to all the ECS, and the ECS can access to the same catalog, and then can move to the container. In service of different languages, we will have a unified hash algorithm. It can access the dynamic access document. And this document, once upgrades, it will have automatic script to drag down to NAS. And Java, Python, and Golang, for every 3 minutes, it will read this configuration document and to upgrade this configuration document. When we receive a request, it can call the unified hash algorithm to identify the corresponding hash machine. So we can realize the unity in Java, Python, and Golang. And also there are other service discovery schemes on Ali Cloud. For example, you can mount on the SLB and expose the gateway, you can identify the service. But the other approach, we don't use it. And next I will talk about the data volume mount. The NAS disk domain is the whole ECS. They use the NAS disk, and another approach is OSSFS. OS bucket, the acting domain is on the service. If within one service they want to share the document, they can use OSSFS to mount some sharing data. We also use this approach to place some configuration information providing service on the Ali Cloud, because this information will not be changed. For example, it's table score, like what is the endpoint, this information will not change. So you can put it on the OSSFS, and each service is isolated from each other. And for NAS disk, all the ECS in the cluster mount to the NAS. Also, we have another data volume mount approach is ECS on premise. Because container could flow from one ECS to another ECS, so this is not suitable for us. Container log. Ali Cloud container cluster platform also provide the sign-on, and it also have some default installations, among which there is the container log. This service is the container of Ali Cloud. So if you use the label in the template, you can transfer all log to the SLS. And also you can use SLS to store on the ODPS. And it can store for 7 days. If you want to see a long-term storage, you can continuously send the log from SLS to ODPS. We adopt this container log function. We also build our own Sentry. This is a very good tool for look at the log. Also, it can realize a one-click deployment. So when you use the container cluster platform, also if you want to deploy other resources, as long as it's in line with the Docker standard, you can have a fast deployment. Sentry is a log aggregation tool. On the backend, every day we have like maybe millions of logs. So Sentry will aggregate the similar logs into one log. And then we can cover more logs within limited time. The last thing is about monitoring and alarming. Is a bottom-up process. So from bottom-up, each layer we have the monitoring function. Now, 50% of O&M actually is sorting the monitoring and alarming information. This is the core task of our O&M. If we see the API or some other useful index, we can use a script to collect and to do the calculation. And then we can report the calculation result to the cloud monitoring of Ali Cloud.
And to the cloud monitoring, and then you set up the value, and then it will trigger the alarm if the threshold value was reached. We like this kind of app, like Slack. It will just send the alarm directly to the Slack. And also, we run into some issues when we use the Ali Cloud. But I believe that these issues will be solved with the iteration of their past products. So I will not read them through, they're just details. So this is our scale. We have 98 ECS, 65 services, 764 containers. That's all for my presentation. Thank you. Thank you very much. Any questions? In the container environment, if we do micro services, it is TCP or CCP. We use SPP. We do not use RPC. We use 7-layer, not 4-layer. Because we have multi-language on our backside. Because many companies have their RPC architecture and a framework, and maybe these developers develop within these frameworks. Our team is in Silicon, and we support 100 million active monthly readers, and we only have 20 engineers. So they are very efficient. If in a big RPC framework, ask them to write business, you won't create such value. But in terms of performance, I think 7 layers is better than 4 layers. And it can improve the performance, but actually all of our business development is very fast. So we need one RPC structure to do the business. I have to, if I have new business and then I have to add on C++ service, I have to do a lot of things to plus on the service. I don't want to be too slow. Or design for failure. I write this code, I know it will fail. So when I write it, I have that in mind. I don't know how others. And another question. And in the Docker environment, if we do service and the boundaries of the service, so our business is quite straightforward, maybe compared with like e-commerce service. Maybe you approach me later.